So I think we can start. So I'm Tero Kivinen, and this is IPSECME working group session, and my co-chair is there. And now you can actually see him because he put some lights on there. All right, so this is the note well. Please note that well. And these are the, we have a couple of note workers. Paul and Anthony already promised to do something, but we are taking notes in the notes IETF.org, so everybody can actually go in there and add their own stuff there if they need it. There's no need to take everything else, everything that is said there. Just what is decided and what is resolution, and if there's some useful comments or interesting comments or questions, you can put those down. But during the presentations, there is no need to type in what the person is. If somebody is interested, they can go and check the recording. All right, so this is our agenda. It's quite full, and we have a couple of those very short 5-minute slots, and I don't know if how well they are going to be. We usually haven't been able to keep up with those short slots, but let's see. Any comments on the agenda? Anybody wanted to add or modify or remove something? Okay, let's go forward. Okay, Paul.
Just a quick note. With the
your name.
Sorry, Paul Wouters, individual. I just wanted to make sure that any other business doesn't get kicked off the list, because I would like to have a little item talk in any other business. So please make sure that it's not like, oh, no more time for any other business.
All right. And as I said, please remember to say your name before you are speaking on the microphone. And also, when you are actually wanted to speak, if you are in the room, go to the Meet Echo and request a hand raising tool for request a permission to speak. All right, so let's go to our working group status. So we have published 2 RFCs since last time. So we have multiple key exchanges in the IETF version 2, and then we have the deprecation of the IETF version 1 stuff and obsoleted algorithms. So those were published since last time. We have 2 documents that are in the RFC editor queue, labeled IPSEC and add IKE. And then we have we don't have any documents that are in the ISG or in the AD, but that will probably be fixed very soon because we have some documents that are waiting for the write-up. So IETF version 2 has been there for a very long time. That mostly requiring me to actually go and read the document and make sure that it actually is, ready to be published and so on. And then there is this auth announce, which we haven't currently in the working group last call, but I don't think I have seen that much of discussion, and I think we left it open. But so it would be really useful if people would actually read it and send the list. I will send a reminder that if you think that this is ready, say so in the mailing list. I mean, if we are not hearing anything in mailing list, that doesn't mean it's actually okay. It means that there is no interest, and then it will not go forward. And I think I have seen like 1 or 2 comments, but mostly for routers. So. And then we have a working process document. We have a TS payloads optional, which I was told that it's supposed to be ready for working group last call, and then I make a like 1-minute check, and so found out that security considerations to be written. And I don't think it's actually that ready for the working group last call. I think working group is actually interested about the security considerations also, not only the ISG and so on. So please write them before you actually before we actually start the working group last call. I hope that the authors will actually make a new version of that and add those things that are missing, and then we're gonna start the working group. And then we have this multi-assay performances. I think there's also some similar type of things that or was it actually this one that has me? Either one of those were actually missing the security consideration. Another one was all right. So, but those are still the documents that you are working on now. Yeah, go ahead now.
So, Paul Wouters, individual. For the multi-assay, I think there were 2 people who had issues related to like the fallback assay and whether there was local implementation should be in a draft. as far as I know, that was resolved by removing it. So I would like to know if those two people no longer have any objections and how to move forward with the document. Because it has been in a stalemate for a bit. I would like to know whether it's dead or alive.
Oh, so that would be a good idea to send an mail to the list and ask those people. I think I'm one of them, and Valerie's the other one, I guess, because we are usually against everything.
Yeah, I won't name it, but yes. But there was a new draft version, so the two of you do need to comment on a new.
Yeah,
draft.
but I mean, even if you make a new version, it's usually a lot nice to send out. Okay, this should solve your issues. Are they solved now? So that then people actually. I usually don't read the draft until I get somebody actually asked me to read it. All right. Okay. So then we go to the presentation, and let's see. So the first one is going to be payloads in the child exchange.
I need to work on my rockstar skills.
More strength.
And my strength. Okay, next slide. So optimized read key support. So there's been a little bit of discussion on the list. Thanks very much to Tobias as well. So there was some more clarification for IPComp, and Tobias pointed out that it needs to be clarified a bit more to make sure that it works. But as pointed out on the list, it can just work for those who want it, and if for some reason people forget this payload to do it wrong, we can just send an error. That shouldn't really happen that much. The more interesting part is that RFC 7296 states that the notify message may only be included if there's an SA payload, and with the optimized wiki, there's no SA payload. So technically, formally speaking, we should update this update 7296, which I know makes the chair really twitchy. So please, I would like some advice on there if the chair and other people think that this is big enough to actually require an update clause or not. Next slide. There's been some talk about the initial child assay. Because you don't know the PFS that the peers would normally want to use on the child assay, because the initial exchanges don't convey that information. Once you do the optimized wiki, you don't really know if they want to do PFS, yes or no, and with what group to do. And so how do you get out of that? How do you get that information? So some people wanted to do just one regular wiki or a childless wiki and then do the create child assay to create the first child. But all of them involve doing lots of old style exchanges, which waste a lot of bytes, and especially for the IoT devices that sort of are provisioned and they know anyway what kind of PFS groups they are sending. That's all not really necessary. They're provisioned in a way that they will have the right IC proposal, and so they know what to do. So it would be nice if the document doesn't mandate that they first have to do a classical wiki anyway before they can do the optimized wiki. So I was hoping that if anyone has really objections in language that sort of states that they would tell me now or on the list soon, because I would like to avoid mandating it. Next slide. And then there was a bit of exactly what kind of error codes to send, but I don't think that matters too much in this discussion. The other things are already said. So next slide. There was an error where what do you do if it's a failure and it's an optimized wiki? You kind of want to make clear that this is a really big failure. And originally, I mistakenly stated that the critical bit could be set so that you know it's a critical payload, and if you fail, then you know it's a critical like it's a fatal failure. But of course, it's a notify payload, and it's mandatory to support on the core spec, so you're not allowed to set a critical bit on it. So that's just wrong. So the critical bit should be removed. We could decide to change the notify and make it its own payload, and then you can set the critical bit, and then you can actually fail that way. But I think again that's just too much unnecessary work. So my proposal is just to remove the critical bit. So again, if anybody has opinions, please let us know here on the list. Next slide. Okay, that's it. Questions, comments?
Yeah, I'm not working there because it's actually too difficult to get partial of this stuff. So this document. So I actually think that because this is an optimizations for things, we should actually just limit things and say that okay, if you are using multiple protocols or you are using CPIs, compression things, so don't do this. Do normal. If you are doing so, we say that this is for cases where you actually have like a situation like in most of these IoT or small devices, they actually have exactly one key exchange payload. They even in the in it. So we can say okay, you can use it in that case. If you have multiple key exchange payload, it always assumes that the one that you use in IKE is the same that you want to use in later. And so we can actually just say that okay, we do it that way. And if in some case you actually want to use it in other situations, then you have to do the extra rekey to tell whatever you want it to be doing in the future. And after that, you can go back to the optimized one.
Okay, so I agree with all the points for that, except with the IP comp, where you really want to do IP comp with the IoT device because it saves bytes, right?
The question is just because I don't think those actually the IP comp is. I don't know, but I think most of the yes, people would assume that it's okay, but I think actually most of the implementations, they don't actually do IP compression at the IoT because the packets are so small anyway that they don't really compress that well. I mean, IP comp is usually useful when you have access because it's a stateless compression, meaning it can only compress whatever is in the same packet. It means that it's not really getting that much of compression if your packets are 100 bytes in total. So, but yes, the IP comp is actually we should probably bring that to the list. And yes, IP comp could be something that we could actually with IP comp. Even in that, I don't think they actually changed the CPI. The compression index is
yes, but if you would omit the payload, then you would actually mean no compression.
No, but I mean,
so you have to include the payload anyway.
No, we optimize it out. We say that we use the same CPI, same IP compression, proposal that was used when we created that. It's a rekey. We don't change any of the parameters. We don't change any of the algorithms. We don't change any of the CPIs because that's the same algorithm. It's one of the algorithms that we are not changing.
Okay, I see that, but then I'm still.
But we should bring to the list. Okay. Ask if anybody actually in the list. So I put somebody put in the notes that Paul will send a mail to the list asking if anybody is using IP compression with different CPIs and would be interested to see this one to working with that. Because I think we should really see if anybody's interested or before we actually start wasting time on that.
Okay. Oh, and I forgot to say there are some rough implementations that have done some bit of interrupt testing on this, but needs a little bit more polishing and more interrupt testing. But we're doing the work there.
All right, so that was the first. Then we go to the next slides, which is the RPKI, and this was presented yesterday. Yes, I can. But one of the problems with this is that then when you give it back to me, it's going to be I have to go to beginning. But anyway, wait, go ahead.
Okay. Hi everybody. This is about RESAV. I'm sorry we have a little bit of a mix-up. We ended up with too many. Last time we had no presentation slides. This time we have too many. I'm going to skip most of what I said in Sec Dispatch. I hope you were there, and try to focus on the specifics that are details that are relevant in this working group. So I want to talk about specifically the protocol that we are proposing here. So just as a reminder, we're talking about doing IPsec, and the interesting thing really about this proposal is that it's IKEV2 IPsec, but the brokering of the connection and the authentication tie back to the RPKI, and the endpoints of the IPsec endpoints are autonomous systems. They are ASs and all the traffic that flows through them. And so because they're ASs, they have RPKI identities. we have some notions about something called ACS, the AS control server and the AS border routers. The important thing there is that there may be a lot of AS border routers, and so potentially even for a single IPsec association or tunnel between a pair of ASs, there could be a multitude of paths between a bunch of hundreds even of border routers on each side. And talking about very large volumes of traffic. And so when I think about what this proposal is about from a protocol perspective, it's about hyperscale IPsec. What if we wanted to do IPsec at enormous scale? We thought a lot about how to make that possible. And in the original draft, we had a fairly novel set of protocol elements. The latest revision has a lot less of that. And what we've done is, as the authors have learned more about IPsec, we've found, and also about outstanding proposals like sequence number subspaces and lightweight essays, we've tried to defer as much as possible to existing or proposed enhancements to IPsec and focused on basically just providing guidance on how you would do this using those existing or planned protocol elements. There is some novel protocol proposals in this draft currently, and those are mostly related to what we are calling, maybe not quite right, the transport mode using the authentication header. I know that IPsec folks are not fond of the authentication header. As I've said, I don't have the history personally. I don't really know why. It seems like in this case, it's potentially a very good fit, and it saves us about 50 bytes of overhead on every packet, which again, if you're talking about operating at very, very large scales, you know, saving a few % of backbone traffic seems like a worthwhile endeavor. And so most of the protocol text in the document is focused on this transport mode and things like, well, if if we're doing this tricky thing of adding and removing IPv6 headers, for example, what does that do to PathMTU discovery? How do we make sure that that ICMP packet too big responses come back across this translation in a way that preserves their correct behavior? And so there's a lot of text about that. But ultimately, actually, you could delete all of that from the draft and it would still work because ESP is also supported. It's just a little less efficient. So for this working group, I want to mention the one more set of details about this, which is replay protection gets really complicated in these scenarios where there's a lot of potential sources and a lot of potential recipients. It seems like one thing that we are going to need, and we've already sort of discussed and I think had consensus on, is to port the replay status thing from IKV1 to IKV2. It seems like it was lost more or less by accident because nobody cared about it. But it seems like it could reasonably be forward ported. That would help a little bit. Mainly what I would like from the group is two things. I'd really appreciate it if some folks would look at this draft and just see if we're holding it wrong. The authors of this draft are not really coming from an IPsec background, and so I'd just love to know if there are places where we haven't quite gotten it right. The current draft says things like that you can use active source redirection in IKV2. This idea that you can say you should expect the packets to come from somewhere else to potentially create separate essays representing each of your border routers so that they don't have to share state. Somebody who understands this a little better, it would be very helpful if you could check us on that. And the other thing I wanted to mention is that the area directors have kindly offered us a mailing list to talk about this since it doesn't neatly fit into the existing working groups. If anybody would like to be part of that discussion and think about this very interesting hyperscale IPsec problem space with us, I'd really appreciate that. Thanks.
May I beg the chair's indulgence? My devices will not let me raise my hand.
Okay, go.
Joel Halpern from Ericsson, but I'm here wearing a more specific hat. I am the SAVNet co-chair.
Okay.
Are you familiar with the work in SAVNet?
So this work descends from a proposal that I believe was called ESAV at the SavNet BOF. The SavNet BOF was looking at a few different proposals and ultimately chose a control plane.
No, it
SAV.
did not. No.
Ah.
Let's be very clear about the state of the work. What SavNet is trying to do right now is a problem and gap analysis for intradomain and interdomain. So I would really ask you to look particularly at the interdomain problem and gap analysis and make sure we have got all the problems. And if you guys have spotted a problem we don't have, please tell us. We will then undertake to start an architectural analysis and a solution approach analysis. And we have not made a decision on what that should look like. There are proponents who, like in every IETF working group I've ever been in, believe that their solution is the right answer. There are at least two of those. They are different. I have no problem as chair if there is a third. So assuming you're not trying to rush through for some reason, I would really love to see you participating in both the current gap and need analysis, and assuming we conclude there is a need for something better in this space, then participate in the architecture and let's see if this is an addition to, a replacement for, or how this relates to the other proposals there. Because I'm in no position to evaluate it from this. I wouldn't expect to. Love to see you participating in the SAV network, please.
Thanks for that invitation. I'm glad to hear that SavNet is looking at this more broadly than I realized. So I think we'll have to take that advice.
Any other comments? So I guess the mailing list hasn't been created yet.
That's right.
Okay,
I think
so
we'll only do that if after we can get some interested parties. So if you'd like to be part of a discussion like that, please reach out.
Yeah. And when it gets created, please send an email to the IPSEC list and tell that the mailing list has been created and so on.
Okay, will do.
Okay. All right, so then we come to the Daniel's presentation. Is it okay that I pass you the slide controls, Daniel? You should be able to now be able to control the slides yourself.
Check. Okay.
Oh, you just need to jump to the slide, whatever we were.
Do you know the number? Okay, slide 30.
You're a little bit quiet. Are you? Make sure your microphone is working correctly. Okay.
Okay. Can you hear me now? Better?
Yes, we can hear.
Okay. So I'm going to present this draft where we're trying to have to negotiate some security association that will carry some traffic with a specific DSCP value. So the goal is clearly to ensure that the traffic associated with a given QoS is taking an expected security association. I'm going to present the way we're doing it with a draft, and the way we're doing it is currently to add one traffic selector. But given some feedbacks we received today, there is a discussion whether that's the right approach or if we should take a notify. We are really open to that, but I'd like to take that session to make sure that everyone understands that we have a problem to solve. So currently, in the security association, the traffic selectors in the security association are basically defined from access control parameters, which is the IP address, the ports, upper layer protocols, and so on, but not the DSCP value. And one thing we need to also consider is that the DSCP value is actually a value that tells how the traffic is being steered, as opposed to where that traffic comes from or goes to. So, I mean, DSCP is not something new in IPsec, and the way current the IPsec architecture RFC is handling this DSCP value is basically saying you need to have a classifier, and that classifier takes the I mean is responsible to associate a DSCP code value to a specific assay. The problem is that if you have multiple assays, it's not given that one traffic will take one assay to go from peer 1 to peer 2B, and that peer B will take that the associated assay for the traffic that goes to peer A. So this is what we're trying to solve. So the way we do that is basically having a negotiation. I'm going to the next slide. So within the traffic selectors, we're saying, this is my assay. These are my traffic selectors, and I would like this traffic being associated some DSCP values. And you provide a list of acceptable DSCP values. And when in the response, you agree which DSCP values you are actually considering. And upon agreement, what we are providing is that you ensure that a given negotiated pair of security association is only associated with some specific DSCP values. So of course, DSCP value can be changed on path. So actually, when you're and the only one we care is the one inside the tunnel. So which means that those kind of traffic selectors are only valid when the tunnel mode is being used. There is also a discussion where these DSCP values can be used to escape one security policy, and for that reason, we need to ensure that every DSCP values. One recommendation is to have the same security policy for every DSCP values, and the other one is to specify each DSCP values. So maybe with a default rule at the end, but that's something we need to look at. So I think this is basically all for this presentation on that topic. Now I don't know if there are any open questions, if there are any questions, or why we are doing it, why we should do otherwise. But if we do have such question, I'd like the people to come to the mic.
All right, so we are a little bit ahead of our schedule, and this presentation was exactly 5 minutes as promised. So we can have a discussion on that, and I think that there has been a discussion already in the mailing list. So any comments, questions here in the group? I think the main comment we had in the list was that people were a little bit confused why you want to be, using DCSP as a selector. Because I mean, most of the people have been saying that, okay, traffic, the quality of service types are not really selectors. They are something that can be changed over time and they are per administrative domain anyway, so I had to do mapping and that kind of thing. So that's really the question, is that why do you want to do that? Go ahead.
Joel Halpern from Ericsson, a co-author on this draft. I hope I can clarify this. I make no claim to being an IPsec expert. You guys know much more about this than I do. The concrete problem we have, and we have observed this in the field, we have two devices. They're not even necessarily from the same vendor, but they're two devices bookending a tunnel of some kind, a GTP tunnel, or more particularly an ACIPRI tunnel is the common case. Whole bunch of traffic going over them. And there's a subset of the traffic that is critically important. So it's marked with a different DSCP. And when it gets to the queues, because of the way queuing works, the disordering exceeds the IPsec reordering protection window. And the traffic which made it through the network just fine gets dropped by IPsec because it looks like it's bad. And if we can separate this out and make sure the two ends are in agreement about what's going on, it seems a natural thing to negotiate that we're doing this over these set of child SAs. If we separate these out, we avoid this problem. Yeah, you can configure lots of things that are more complicated to configure to do it in a harder way, but that's the fundamental problem we're wrestling with.
Yeah. So, and the answer has been always to that RFC, architecture, IPsec architecture already says that if you have a traffic that has multiple, different quality of service types that might cause this kind of things happening, you put them in different SAs, and that's why you must be able to configure that kind of setups. That's already there. So it's more or less an implementation I would say implementation bugs that they actually put them in the same SA. The other solution that, of course, is to make the replay, window much bigger.
And I wish we could do that, but so far we have not been able to deploy either of those solutions, which is why we're looking at this.
Yeah.
I don't know all the real world limitations we've run into, but I know we've tried to work our way around this and had a lot of trouble. This has caused us real issues in real deployments.
Yeah. All right. Okay. Any other comments?
So, but
right, let's
also the other, the other issue is that with what the IPsec architecture document says is that, you can have this kind of selector that split the different DSCP values between different SAs, but it doesn't mean that you end up with the both peers using exactly the same SAs also. So it actually ends up in managing the tunnels it makes the tunnel management much harder because you're not able to bind a given flow to a given tunnel.
Sorry, I tried to get
Yeah,
it on the
all right,
app.
go.
Christian Hops. I was curious, how big of a window do you need? I'm just curious how disordered it gets. Do you know?
I don't have those numbers. I'm sure that if we had the full window, it would probably be big enough, but we don't.
Right.
Some of the implementation we have to work with.
Don't support going big. Yeah, because Tero said it's really easy to do like huge windows.
I mean, most of the implementation do have settings of windows. There is, stupid implementation that has a default window of 32. I think, implementation driver, I think the default windows are 1,000 bits or 1,000 bytes, 1,000 packets, which usually is quite a big, and it's 1 bit per, per, window size. So it's actually making it a bigger. It's actually not that costly.
Right. The reason I asked the question is because, with the 100 gig link, you might have a lot of packets in between.
Yeah.
So
Scott?
They could, but I think most implementations just do the 64-bit because it's easy to implement.
Okay. Scott Fluer, I'd like a clarification on something you just said. You said that one of the problems is that if the two sides don't agree on which SAs to send to traffic for the different DHCP, it's unclear to me why you care. If one side decides to send the traffic through SA1 and the other side sends it through SA4, why doesn't it work out?
So it's suppose you want to move that flow the flow taking SA1, SA2, and you want to remove that SA. So you actually cannot remove that SA because otherwise you may end up you clear. I mean, you only manage SA by pair. So if they are not taking the same the same pair, I mean you cannot delete completely that SA, or at least it's an the way the other pair is handling that is unknown.
IPsec can handle deleting SAs and sending traffic through another SA, which is already been negotiated. I really do not understand the problem.
All right. So I think Joab, you are next.
Yeah. Daniel, when you're encrypting and encapsulating a packet, are you copying the DSCP value from the source packet to the ESP packet?
So I don't know what our implementation does exactly, but it is not something I'm mandating.
Well, I remember the
I would actually assume
switch for that.
I would actually assume it must copy, because otherwise there wouldn't be any difference in the network. Meaning, if you say that you have a reordering happening,
Yeah.
that means
Right.
that you have to have a different
No, the
DSCP.
typical case,
Otherwise,
we're
the problem
copying
doesn't arise.
from the inner to the outer DSCP, because we have differential treatment in the packets we're being handed, and we need that differential treatment applied to the resulting encapsulated. So the typical case, yes, we are copying the DSCP outward. The Security Association, obviously, it doesn't depend on the exact value, but the functional behavior is being copied, yes.
I think that explained to Scott why the problem is what the problem really is. I think that is the problem, that you're copying the DSCP and therefore getting rearrangement of the packets after encryption and encapsulation.
All right. Any other comments? No, let's go forward then. Daniel, you have the next presentation also. And it's at the same slides. Let's just go forward a couple of slides.
Yeah. So, okay. So here we're solving an issue we have, which is fragmentation. So no. Oh, I didn't. So when fragmentation is happening on the network, when you perceive to fragment, you actually have to reassemble those two fragments, and that costs some resource. And this is the situation we want to avoid. So those fragments happens in two ways. The first way is the first scenario is when you have I don't remember how it's called. When you have the mid-tunnel fragmentation, which means you're sending an IPv4, you are encapsulating into an IPv4 packet with the down fragment bit set to 0, and you have a router in the middle that is fragmenting that packets. So the egress security gateway is receiving those fragments, and one thing we need to understand is that the ingress security gateway is not aware that fragmentation occurs. So what we would like that the egress gateway can actually inform the ingress gateway that fragmentation is happening. And the expectation is that that ingress gateway handles its packet handling so that that fragmentation does not happen anymore. So the other way fragmentation can be observed is when the ingress security gateway is actually performing the fragmentation. So this is called outer fragmentation. In that case, the ingress security gateway is well aware that it is performing fragmentation. That fragmentation is happening because, I mean, it is performing the fragmentation. So what do we do then? Yeah, so the basic thing is to understand is that if you have fragmentation, at some point it means the packet was too big. And so the idea is that the ingress security gateway adapt itself, so inform the sender that its packet is being too large, and to reduce the size of the packet. So in order to do that, to inform and to interact with the senders, we do rely on the existing mechanisms provided by the IPsec architecture. So this is not something we're changing. So on this figure, what we can say is that given the size of the packet to be encrypted, I mean, when it's sufficiently small, there is no fragmentation. Then when it's a little bit larger, we can end up into fragmentation. That fragmentation can happen at different, either within the network or directly by the ingress security gateway. And when fragments are way too big, then we can end up in a packet too big to be processed by the egress security gateway. So we're basically creating two messages. One which is telling simply that enables the egress gateway to tell the ingress gateway that fragmentation has occurred and the size of the initial fragments was that amount. And the other message that we are sending is when the packet is so big that we cannot even attempt to decrypt that packet. So one thing we need to be very clear is that when I'm sending link maximum atomic packet notifications, meaning fragmentation occurs, in many cases, it doesn't mean the packet has been discarded. It just means I'm working, you're giving more work than you could do. But this is part of the normal way to handle the traffic. So what we're doing is basically an optimization. When the packet is too big, it means simply the hardware is not able to end up with that size. So here is an example of an illustration. So we are taking the example where you have a mid-tunnel fragmentation. So the egress gateway receives two fragments. When it receives the first fragment, it provides the IP version as well the fragment length in a notify payload. And when the ingress gateway receives that fragment, it asks the source or the sender to adapt its size of the payload using the regular ICMP packet too big, but that's well-designed mechanisms from the IPsec architecture document, so not anything new. So where we are now, we're basically at the same state that we used to be at last IETF. We had many comments from the transport area, basically Joe touched. We addressed most of them, but we cannot say we found ourselves in a complete agreement. And the disagreement is basically that for according to the interior tunnels draft, I mean the inner packets and the outer layers should be completely independent. On the other hand, so for them, having some fragmentation is not an issue. But according to I mean the IPsec architecture document, it is well understood by IPsec that we can adapt the inner packet size in order to avoid some fragmentations. So at that point, it's I would say it's what we believe it's a design, but I don't think I mean, the draft itself is not doing anything that IPSEC was not doing in the past. So I see Christian in the line.
Hi, yeah. While I was trying to figure out how to put myself in the queue, I might have missed something you said. So I'm sorry if I'm
Yeah,
asking
sure.
a question you already answered. So that you have two different notifications. The second one is the packet too big at the egress, right?
Yeah.
Since you control, right, in this case, you control the SA, you control the tunnel, right? So you're controlling what traffic you allow or drop. I mean, the classic problem with PathMTU discovery, right, and getting that information back to yourself is that some middleware box drops it, right? But you control that. Like, you own the SA. So it would be literally you yourself dropping the packet that you want to see.
No, it's when you have multiple fragments. And to decrypt those fragments, you need to reassemble those and then perform the decryption on that.
Right.
It may happen.
So what I'm saying is the egress, we're in the situation where the egress has reassembled things, right? And it's saying, okay, this packet is too big for me to forward onward. So I'm going to send that second notification you just mentioned. But what I'm saying is that notification is an ICMP too big message. You just send
it's very
that
close
back.
to. Okay.
No, but I'm saying the only reason that won't get back to your router is because you yourself dropped it, because it's in your tunnel. So I don't think you need this, is what I'm saying. I think, you know, you've administratively shot yourself in the foot, and then you're like working around that damage by trying to create a new, you know what I'm saying? Just don't do that in the first place. Don't drop your ICMP too big message.
Yeah. So okay, I see your point. But the thing is that apparently those ICMP packets are easily dropped, even not by yourself necessarily. But
they don't know.
No, but you're saying it's in
anybody
the tunnel.
Anybody dropping it, they're randomly dropping it, right? They can't see that. They can't see the message. It's encrypted in your tunnel.
I'm taking that back to the thing, and I will try to. I'm happy to remove that message. I will see that how I can do that.
Yeah, I mean, make sure that I'm not missing something, but just wanted to point.
Yeah, but me either. I will get back to you in any case.
Hey, Ben Schwartz, Meta. Yeah, it seems like really the key thing here is to set don't fragment. If you don't want to reassemble on the other side, then you need to set don't fragment at the sender, and then you need to do some path. Hopefully, ideally, you'll get packet too big responses. Failing that, you need to do some path MTU discovery. But I don't think you need any new signaling. You need that recommendation.
So we do have if we could set the don't fragment bit on, we won't need that. But we have a complete section where we explain why we can't do that, and it's basically black holing.
So I think that, you know, the sort of best practices from transport at this point are to set don't fragment, and if you need to work on through black hole networks, then you need some sort of packetization layer path MTU discovery. You need DPL PMTUD, and that's no fun, but it's the best we have.
All right, but we're running out of time for this, so I think we should take this to the list.
Yeah. So just as a short answer, I think everything Ben said, we have it in the document, and we said why it doesn't work.
Okay.
We also have an implementation, and it solves our problem. So
Okay.
next presentation.
And now we are on time, so now you have only 5 minutes.
Okay. So header compression profile. So these are drafts that have already been presented in the past. Basically, we stopped working on those because we were waiting for. Well, I can show the slides maybe. Yeah. So we were waiting for the generic framework for static context header to be published. And so that framework defines how a standard way of how you can compress the packets. So the intent is that we we wanted to avoid to define for each field how we compress that. So we waited for this chic protocol, and then we described everything we described previously using the chic syntax. So that's basically what we have just done now. So this is a work that will be done jointly with the chic working group. They already started implementing that with OpenChic. So this is what we are working on. There is a discussion. So I think between the chic working group and maybe IPSECME, where this work should be hosted. I let the chair decide. But if IPSEC doesn't want it, we will do that in chic. So it's not an issue. So what we do here, we have we basically start. We both peers are agreeing on a context, and then this context provides all the necessary parameters to do the compression and the decompression. Compressing an encrypted packet is quite hard. So this is not what we're really doing. We're compressing the clear text packet, then we do the encryption, and then we're compressing the header, the ESP header of the encrypted packet. So basically SPI, a sequence number. So why we do compression? It's basically we can end up in a traditional VPN scenario by removing 32 bytes on every packet, and this is pretty interesting for us to have that prediction. So this is what we have in the EHC context. So some parameters are new, but as you can see, most of them are already provided when we do the negotiation, the IKE negotiation. So at the end of the day, there are a very limited number of parameters that we need to agree on. And we agree on using a notify payload, an IKE extension. And this is how we designed that. So we provide a set of proposals, and each proposals contain a number of parameters. And then the responder is selecting one of those proposals in a very similar way as the essay. The essay is being agreed with IKE. So nothing new. We are also, so this is the proposal payload, and all the parameters we're reusing the attribute format, so that it's a structure that IKE is very familiar to handle. And we are, I mean, we designed, we just defined the attribute type, which are parameter code points. And because the way we're doing it, I mean, we are designing a profile, but we also enable other people to define other profiles. So we start a new profile INA registry. Paul.
Paul Wouters, individual. Can you go back to the slide that has the notify payload on it?
No.
There's a little bit of a delay between, so
Yeah.
yeah,
Okay.
this one,
This
yeah.
one.
So I see all these parameters like EHC context ID equals blah. Is that like ASCII strings being sent as a part of the payload of that notify, or are these integer numbers that have names later on?
No. Oh, okay. So these parameters are actually the attribute type packets that you send.
But so no, I mean the notify payload is EHC supported, and it has
Yeah.
a payload data, and in the payload data has something that you wrote down here in sort of ASCII things. And I'm wondering if that payload is actually this ASCII text, or whether
No,
this maps to some other registry.
It was the next payload where we were explaining using the attribute types and that kind of values, similar thing that we use in the C payload. But I think we are now out of time,
Okay,
and so
okay,
let's take to the list.
Yeah, there is no text.
And both of these actually, I think, are in our charter. We actually have a list or item there that we should actually work on compressed, ESP and stuff. So I think these are actually one of those things that are in the charter. So we should be discussing this on the list. All right. So I think that's
Done.
Any other questions or anything else on this? All right. So then we have a next presentation, which is undo-replay sequence number subspaces for traffic engineering. All right. Okay. Let me see. You should be now getting the, control for the slides.
Okay.
Just go next slide and so on. It should be working for you. Good.
Okay, great. Thank you so much. Hello and good morning from Singapore. I'm Mohsen from Cisco Meraki, and today I will be presenting the version 02 of our draft on anti-replay sequence number subspaces. Quick recap of the problem statement. We propose to use multiple sequence number space subspaces instead of multiple child essays for multi-score performance, QoS, and multi-path traffic. In the last draft, we added an IKE transform to negotiate max number of subspaces. We also increased the sequence number field and ESP packet to 64 bits and added the subspace ID in the most significant 16 bits of that field. I will not be getting into too many details about why creating multiple child essays is not ideal, as we have presented about that in the previous meetings. And this is also discussed in more detail in a presentation called ESP problem statement by Stefan Klesser, happening later in this meeting. Right. We are currently implementing the current version of our draft on the vector packet processing open source data plane framework, which we intend to publish in the coming months. We are also working on a closed source implementation, which is intended for deployment in Cisco Meraki's close to 2 million devices worldwide. Finally, these are the updates in the current draft. We have made it mandatory for the subspace ID to be between 0 and 1 minus the max number of subspaces negotiated by IKE. This is to improve the security and performance when using subspaces. Also, extended sequence number must not be negotiated by IKE. when using subspaces, because subspace negotiation implies that the packet contains a 16-bit subspace ID and a 48-bit sequence number counter. We have also clarified that the 48-bit counter must not be allowed to cycle. If any subspace is about to cycle its counter, the SA must be renegotiated. 48-bit counter is sufficient enough to last up to 39 days on a 1 Tbps connection. Also, unlike ESN, the integrity check value calculation is done from the beginning of the ESP SPI field to the end of the encrypted ESP payload, since the entire 64 bits of sequence number is explicitly included in the ESP header. Finally, we also have an IPR disclosure for a patent held by Cisco Systems called anti-replay checking with multiple sequence number subspaces. Finally, we support the problem space statements and use cases for lightweight child security association draft, which discusses using multiple sequence number counters and which will be presented in the ESP problem statement presentation later on. We also welcome any support on the mailing list or on the mic during today's meeting, as we have been given feedback that there is not enough activity on the mailing list. As I mentioned earlier, in the coming months, we intend to deploy this on Cisco Merari's devices worldwide. We would like to deploy this as a standard adopted by the working group. The question remains, should the working group work to adopt this as a standard, or should this remain a draft-based extension? Thank you.
Paul, go ahead.
Paul Wouters, individual. I think definitely it's worth having this as an RFC, I think, at this point, because there's enough people interested. But I remember at the last IPSEC meeting that there was another IPR claim that I haven't seen moving forward in an official announcement. So I think there's now 3 IPR claims on this. And so this makes it really hard for open source software to implement this if we don't get the proper disclosures. So I know that for SSH just only gave a disclosure. I'm assuming here there's a Cisco one that gives the disclosure, but there's a third one that was mentioned at the last meeting.
We didn't hear anything about it. We didn't get any emails. Actually, in fact, a Google search also didn't really show up anything. So if there is one, and please reach out to us, because right now it's
so I don't know. I only know the person who relayed it from last time. I don't know actually what the companies that is involved there. So I will reach out to that person and see if we can get clarity on that. Then.
Yes, please. Thank you so much.
Any other comments? Discussion? No? All right. So then we go forward, I guess.
Thank you.
So the next one is Valerie. And you should be getting the slide control now. Okay.
There are too many slides.
Yeah, it's everything in the beginning, and so it's actually depending. If you don't use arrow right or left, instead of click something, it actually goes to very beginning.
Okay. Well, a few words about IKE Transport, and just a reminder, and IKE originally used UDP as a transport protocol, and depending on the presence of nets, ESP either runs on top of IP or were UDP encapsulated. And later RFC 8229, and it was updated 9329, extends IQ2 to use TCP. When UDP is blocked, is unavailable for some reason. And in this case, ESP is always TCP encapsulated. So what is the problem? When IK messages grow in size, for example, when we use multiple key exchanges with post-quantum algorithms, we have some problems. We may run into some transport problems because UDP isn't a reliable transport, and IQ2 uses a very simple retransmission mechanism that just resends packets if no response is received. And even when IP fragmentation solves the problem with IP fragmentation, but still all the packets, all the fragments, IP fragment packets are sent at once. So it is not very friendly for congestion control. So there's no congestion control actually in IQ2 with its retransmission mechanism. And with large messages, it can be problematic, especially if you're considering such post-quantum algorithms like classic MAC-Elise, which is not adopted by NIST, but is still in the round fourth candidates. And using reliable transport like TCP solves the problem with transmission of IK messages, but at the same time, it introduces a problem with ESP because reliable transport for ESP makes the performance very bad. It's called TCP in TCP, it's called TCP meltdown, and we cannot get high performance in this situation. So what solution can be proposed? Just decouple transport for IK and transport for ESP. So use reliable transport for IK if it is needed, and continue to use unreliable transport for ESP. How this can be done? First, to use this feature, it should be negotiated. So IK SA needs is started using UDP port 4500 to verify that UDP packets are routable. Those UDP packets that can be used for UDP encapsulation in case of NET is present. And so if both P and includes a new notification reliable IK transport. And if peer successfully exchange this notification, it means that they can switch IK to TCP in the next exchange. So the next exchange, whether it is IK intermediate or IK auth, is switched to TCP, and all messages sent in the IK SA, in this IK SA, and all the keys IK SA continue to use TCP as a transport. And at the same time, all child SA that are created with this SA and with Rekit SA use IP or UDP encapsulation, depending on the whether or not it's present. So some details: not keep alive message must be still sent over UDP, and usually it is IK which sends these messages, despite the fact that IK itself runs on TCP. And peer should not try to switch IK SA and UDP if IP addresses change and mobile is in use, as it recommends in RFC 9329. And there is some issue with this. So if IP addresses are changed, we don't perform return readability check on UDP. So it is still an issue with this proposal. I don't know how to better resolve it, address it. And just a question with this approach, perhaps we can make a reliable like transport negotiable, for example, to use quick in this case. It's just an idea. It's not in this draft currently. So just thank you. Any comments and questions? Is it an interest in this work? Just tell.
Yeah, so just giving us individual. As you noticed, there was an email coming today to the IPSEC list talking about ESP ping, which would actually allow to use this. If you are using reliable TCP for IKE, it would be actually interesting to know if ESP works or if you have to use UDP encapsulation for ESP. So you could actually use this ESP ping to do that, to actually know this, verifying that the ESP works. I don't know if that actually could also be used for the return routability checks for mobile. It doesn't really, you know, because if the only thing that we actually we need to have something coming back, we are not really doing any security process, if I remember correctly, from mobile. That would be actually one option. But it's actually would be interesting to think about that. So just for comment.
Yes, thank you.
Any other comments on this?
If there is any interest in this work, so I think that draft can be adopted or issued call for adoption.
So as a chair, I was supposed to do, you know, I was thinking about having adoption calls in the end here a lot, or all these kind of things, but then I realized that our AD is not here, and I actually want to talk with our AD first about a little bit, you know, which of these are actually in charter and which are not. So I will actually postpone all of my adoption calls to after I have been, you know, I chase our AD somewhere here at some point and corner him and ask, you know, verify that everything is okay before I make these, and whether we actually need to change update the charter. Actually, updating the charter is not a problem. We can do both actually, and we just like actually require some things to be, you know, starting the charter update before doing the. We probably don't need to wait for the charter update to go through before that. All right. Any other comments on this? All right. So next. I now have to be very careful not to click on anything, but just next, you have to go right or left. If you click on anything on the screen, it actually jumps to that slide. All right. So, yeah. And just say when you want to have next slide.
Yeah, okay. Yeah, hi. I'm going to talk about the ESP problem statement draft that we published at the beginning of the year. So
probably need to be closer to the microphone.
Yeah. Next. Okay, so ESP has a couple of problems in these days networks, and the most prominent one is replay protection. I mean, there were already a lot of proposals to fix this. I mean, even today we've seen already two. So I think most of the people here in the room can feel the pain we're getting from there. And that's actually what we are discussing in the draft I'm talking about. So another thing is the header and trailer format, which might not fit anymore into all use cases, but that's still a to-do in a draft. We plan to cover this in the next version. So yeah, for now we cover for replay protection. Next. So let's have a look at replay protection. Next slide. So we identified 4 problematic scenarios. One is multi-core, quality of service, multipath, and multicast. And if you look at that, you'll see that they all have something in common. They all introduce reorder. And that's the root cause of all the problems here. Additionally to that, we have 2 scenarios that needs additional synchronization, which makes the situation then even worse. So let's see how we can solve that. Next. So we identified 5 possible solutions. The first 3 of them do not need any changes to the standards, while the last 3 need a bit of a change of the standards, but we will see that later. Okay, next slide. So first, let's have a look at what happens if we disable replay protection. I mean, apparently this solves all the problems about reordering and synchronization in a trivial way because we don't have replay protection anymore. And of course, it doesn't need any change to the standards. But of course, that lowers the level of security, and it has a downside that we still can't parallelize anything over multiple CPU cores because we have all the same SPI here on the packets.
Ben Schwartz, why can't you parallelize the receive?
Because we have no key to parallelize it. It's all fitting in the same SA, so the outer header looks the same on each packet.
Yes, but you can spray them across cores at random because...
No, that you should better not do.
Why not?
I mean, you're getting reorder in
well, but you just said there's reordering already, and you're trying to tolerate reordering. So reordering the packets.
but reordering in the inner packets, that's what you're getting. If you spread it randomly over the CPUs, you're getting your inner packets reordered, and TCP doesn't really like that.
Okay. It's interesting that that's the concern here. I think that is going to be true of any solution to this problem. You're always going to have reordering of the interior packets, but I'll listen.
Actually, my comment is I don't think actually there would be that much of reordering because I mean all of the CPUs are probably about the same speed. I don't think there might be one packet going in front of, but I mean if you are. Yeah, but it's very small amount of reordering happening.
If some CPU decides to watch a movie, then you're lost, I think.
Yeah, I mean, just to justify what he's saying, right? There's a 5-tuple that's used a lot, right, to put a flow on a specific core, right? The problem is you can't use that for the same reasons you want that to happen for regular TCP traffic. Stefan wants it to happen for IPsec.
Ben Schwartz. So, first of all, what I'm trying to say is that the point of this is to tolerate reordering, which means that the packets are already arriving out of order. Maybe you could argue reasonably that strategy would make the reordering worse, but you can't argue that you don't have to tolerate reordering with, like, you have to tolerate it either way, just maybe more of it or less of it.
Yes, I think you're getting problems with that if you try it.
Okay.
I'm pretty sure.
The other thing I want to say is you do have more entropy that you can use here. If you disable replay protection, then there's no real need to use the packet number for the packet numbers to be in any particular order, which means that you could use them to categorize your different flows and then have stable.
But you still don't know what's inside, so you can't decide that. But let's continue.
Yep.
Next slide.
I believe what you really mean is you don't want to introduce reordering for traffic on a particular flow, and the problem is that you don't know flows until you actually decrypt.
Right. Okay, so what else solves? Actually, it solves 3 of the 4 cases. It solves multicast, multipath, and quality of service. But the multi-core case is not solved because it just solves the problem on the transmit side. As I said, or what we discussed, we have just one SPI and we can't distinguish. And also it lowers the level of security, so we would not recommend doing that for the general case. So next. So next thing you could do is just to increase the anti-replay window size. Also there, no changes to the standards needed, but you still need synchronization then between cores or multicast standards or whatever. Also the receive size has the same problem, so we can't parallelize as we want that. Another thing is that the anti-replay window can grow as much as you want because you have to hold quite a lot of state if you grow it rather big. Another thing is the configuration. I mean, it might be complex because, I mean, which size fits for your use case? It might vary over time and it might get rather hard to find the real size, a good size for the anti-replay window. So next one. So basically this solves the multipath and the quality of service case in case you get to figure out how big your anti-replay window should be, but it does not solve multi-core and multicast because we still need synchronization. So we would also not propose that for a general solution. Next. Next thing you can do is just using multiple IETF. Well, also there you don't need to change any standards, but here what you're getting is you get independent sequence numbers and anti-replay windows, so you don't really need to synchronize anymore here. And also, so you get distant SPIs, so you can do RSS on the receive side and you can parallel based on that. Disadvantage here is, of course, that it's a huge overhead, negation, state, time, and so on.
Are you actually talking about multiple IC essays or multiple child essays?
Here I talk about IC
essays, okay.
Yeah. And what's also, has a kind of an unspecified failure model. I mean, what happens if just the subset of essays gets established? Is this failing or working? So we have to think about that, what should happen then. Next. So basically, this would solve all the cases, but it would not solve one thing. No? Okay, let's come to it later. So, combinations of different cases, it wouldn't solve because it would lead to a combinatorial explosion of the number of essays. Also, it's that scalability issue, so we would also not propose that for a general solution. Next one. So next you could do is just use multiple child essays. This is a minor change to the standard. We still have independent sequence numbers and anti-replay windows, so we don't need synchronization on the TX side, and same on the RX side because we have distant SPIs, so we can do SS there. Disadvantage is inherited from the previous case, of course. It still has overhead, but it has much less overhead than the multiple IETF case. And it inherits, of course, the failure model. Next. So that would also solve all the cases. The multi-core case is implemented in a draft I have here. And I think the quality of service case is that what Daniel is trying to do. Again, this does not solve combination for the same reason. And it still does not really solve the generic case, but that's kind of the low-hanging fruit. So without quite a lot of work, you can already solve a lot of use cases here. Next slide. The last thing you could do is using multiple sub-child essays. So the idea was already presented here in the meeting. So it is just use multiple sequence counters per SA and then encode the sequence number counter ID on some header field. Here there are multiple possibilities to which header field to choose. And to me, at least, it's not yet clear which is the best one. Next slide. So I think actually there are three. So you could just use some bits of the sequence number that was done in the subspaces draft in the first version, but unfortunately that reduces the available sequence numbers per subchild assay and it's probably only suitable for the ESN case. Also, it has a bit limited RSS support because NICs don't do RSS on the sequence number because that doesn't make sense currently. What else you could do is just use some bits of the SPI. Here you would get RSS because current NICs already do that. SPI is a known field, and that would just work out of the box. Or the last thing to do is use a next new header field. That's basically what's done in the version 2 draft of the subspaces draft. They transmit the full 64-bit sequence number and take out a couple of bits there to encode it. That's, of course, the biggest change to all that standards. And again, it has limited RSS support because we have a new header field and NICs don't know about that currently. Next slide. Well, advantages is the same as we had before. Independent sequence numbers and anti-replay windows. We have distinct SPIs to do RSS. But now we have not really rekeying overhead and a clean failure model because we have only one SA between the two gateways. So that's what we are getting more with this approach. Disadvantage here is, of course, it's the most complex change we can do, and we have to care about security implications. Because, for example, IV must not repeat in counter modes, and we have to care for packet byte or rekey limits because they must apply to all sub-SA combined. So you have to do a little bit calculation to get it right here. Next slide.
A minute.
Okay, yeah, well, this solves all the cases and even the combinations of cases. But as said, most complex change, and we have to take care to get security right. So I think what we need to do here, we have to choose a header field. So we identified 3, SPI, sequence number, or new field. We have to pick one. But this might solve the general case, and it's worth to continue this approach. Next. I think I will skip this for time reasons. Next. So my question is the working group interested in continuing this work? Should we make it a working group item? So I'm happy to hear comments on that or questions.
Ben Schwartz, I like the subchild essays approach. I think I can't speak for the group at all, really, but I think it's worth pursuing. And in terms of security, you might want to think about using a key derivation function to generate distinct symmetric keys for each of the subchild essays. That's very computationally cheap, and the key separation would avoid this kind of aggregate limits most likely. It's a little bit like a regular child essay, yes, but it avoids but it avoids end Diffie-Hellman handshakes, right?
No, because the equation 2 allows you to do the child essays without Diffie-Hellmans, and you can actually, multiplex them because there is a window size. You can do tens of them at the same time without round trips. Of course, certain implementations don't support these features, but they don't support this feature either yet. All right, Joab.
Yeah, so with no hats on, I like this solution. I also like the parallel child essays solution because I implemented this once. Yeah, I think the working group should take on this work strictly as an individual.
And this is one of the things that I actually really need to talk with the AD to ask if he actually, because this would be modifying ESP, and this is making ESP version 4 is not necessarily minor extension to ESP. Okay, Paul, you had something on the any other. I asked, is there any other comments on this thing? And I will skip the adoption call, and Paul was having about the open discussion. If it's okay for you,
Yes, sure.
Okay, so very short. So,
Is it a question for
No,
me?
no. So very short. This working group has a problem that it's doing work every 4 months for 2 weeks in a row. This is a problem of everybody involved here, including us, authors, audience, and chairs. I propose a attempt to fix this, at least briefly, by doing an interim in like 2 months from now, so that we at least get a somewhat faster cadence until we figured out how we can actually work without only doing work at the physical meetings.
Okay, and I'll channel Daniel from the chat room. This is interesting. Hardware have limited essays, limited number of essays. Which is, I guess, meaning that
So
why
just to
it's better
clarify,
to do this instead of multiple parallel essays, one for each core.
my proposal and complaint was all purely speaking on personal. I am not an AD for this group. This is just me as an individual.
Oh yeah, this is Daniel responding to the proposal.
All right. So
I do not want to be shot.
Okay, anything else? Any other comments, any other discussion or open issues? I will actually talk with our ADs about these new items and then check out which of them actually are within a charter. I think lots of them are already in the charter or are minor extensions. We can do them. Some of them might be bigger. But we will do next work on in Prague, right? And nothing before.
All right, we got 2 minutes for any other business.
Yeah. All right. Everybody's already running out of the room because it's a break. It's a the snack break. All right. Okay. So we are done. Thank you.
Thank you.
Yes and no.
If I click on now, Thursday lights up.
Yes.
I do that the whole day.
That was modified by somebody else.
Okay, cool.
This is the original idea. For now, it was for me. I think was from me, and it was stopping correctly at that point.
Yeah, maybe it's doing UTC, but I don't know. No. It can't do UTC. I did it early.